So in today's notes, we are going to go over the 3.4 arithmetic sequence notes. So a sequence is an ordered list of numbers that often forms a pattern. So this type of sequence, we are going to be looking for the common difference. And then we need to remember that each term or each number is a term of the sequence. So 26 is our first term, 39 is our second, 52 is our third, fourth, fifth, and so on and so forth forever. Now, to see if this is a arithmetic sequence, we need to start from the back and subtract. And we need to see if we have a common number. So 78 take away 65, 65 taking away 52, 52 minus 39, and then 39 minus 26. Now, if you do that into the calculator, you are going to get 13. Since 13 is the same number, that's why we call it a common number, a common difference, because we subtracted. So we can say it is an arithmetic sequence because the common difference is 13. So then for your turn, you would do the same thing. 9 minus 10 is negative 1. But look what happens. 10 minus 13 is negative 3. Negative 13 minus 18 is negative 5. So right away we know that this is not an arithmetic sequence. So no, because there is no common difference. Now, the two formulas that we will be going over is the recursive formula and the explicit. The recursive helps us find the next few terms, where the explicit helps us find a term in the future, like the 100th term, the 200th term, something that you don't want to keep doing the sequence over and over to find. It's going to be a rule that you can plug in the term that you're looking for. So it says write a recursive formula for this sequence. So if you do this, you are going to get the same number of 4. So this will be 4, 4. So our common difference is 4. Now for a sub 1, it's going to be the first number that we are talking about, which is 81. So from there, we need to kind of follow suit. So this is the recursive. It's saying the nth term of a sequence, so that's why it's n, equals a sub n minus 1, which is our previous term, plus 4, which is our common difference, and then a semicolon where a sub 1 is 81. So you always want to start you always want to give the reader, whoever it may be, where you're starting at. The reason why, so this is our first term, second, third, fourth, fifth. What happens if we want to find the 6th term, a sub 6? Well, this right here is telling us that we need to look at our previous term, which is 97. We're going to put that there. And then we're going to add the difference. So our 6th term is 97 plus 4, which is 101, which is our next number in the pattern. And then you can do that for a sub 7. Our 7th term will be 101 plus 4, and so on and so forth. So that just kind of gives you an idea of why the recursive is ideal for just finding like the next term. Now, for this problem, we're starting at 47, so that's our a sub 1. Our difference, if you subtract these numbers, is going to be negative 8, and that's okay. We're allowed to have a negative number. So that's our difference. You just want to make sure that you're doing your calculations right. I recommend doing it all. You get negative 8 for all of them. And then we're just rewriting the recursive. So a sub n equals the previous a sub n minus 1 minus 8, where a sub 1 equals 47. Now notice in my first example, I wrote it with a semicolon, or I used the word where. That's fine either way, it doesn't matter. And now for the explicit, this is really helpful when we are trying to find a term in the sequence, a specific term, the 12th term, 200th term, so on and so forth. Now, if you notice example 2 and example 3 are the same numbers, I did that on purpose. Our a sub 1 is going to be 81. We already found that. And then we already found our difference, which was 4. Now, I wish I would have given you more room. I apologize. So this formula says a sub n equals our a sub 1. So now we're identifying our 81 plus the n minus 1 times our difference. So for this, we have to simplify. We have to distribute, even though the 4 is behind it. And then something that we haven't done in a few weeks, we have to combine like terms. So when we combine like terms, remember 81 minus 4 is going to be 77. We write the 77 and then bring down the 4n. So that's the explicit. Now, it tells us in our problem to find the 12th term. So a sub 12, this is just labeling, okay? You don't have to do anything with it. You're just telling the reader that you're looking for the 12th term. So now we're going to do 77 plus 4. And instead of n, we're doing the 12. So n is our 12. Now in the calculator, all you have to do is a 77 plus 4 parentheses 12. And you're going to get 125. So what this is saying, our 12th term is going to be 125. For your turn number 3, we already identified the a sub 1 to be 47, and we already identified the d, the common difference, to be negative 8. So we're just rewriting the formula. A sub n equals the 47 plus n minus 1 times the negative 8. So we're going to distribute. Going to keep the 47 there. Negative 8 times n is negative 8n. Negative 8 times negative 1 is a positive 8. And then once again, we haven't done this in a couple weeks. We're going to combine like terms. And we're going to get 47 plus 8, which is 55. Now, I did plus negative. You can do minus. That's fine. So a sub n equals 55 minus 8 sub n. I'm sorry, 8n. So it says use this explicit formula to find the 8th term. So here n is 8. So we're just label. We're not doing anything with that. And now we're going to start with 55, take away 8, and then times 8. So we're going to throw that into the calculator. 55 minus 8 parentheses 8. So, sorry, that should be parentheses. So that should be negative 9. So that means our 8th term will be negative 9. Now we're going to go over these answers tomorrow, so make sure that you are practicing this so we can go over it.